Hello, welcome back to the channel. So let's do a difficult question now and revise the concepts that we learned in the previous video. So this question is about taking the derivative of an definite integral, and as we discussed in the last video, when you have to take a derivative of the definite integral whose endpoints are also functions, we usually use this formula. So what you do in order to solve these type of questions is you identify your f of x for which you're calculating the definite integral for, and then first you plug in your upper endpoint into the function so that you have f of h of x, and then you take the derivative of your upper endpoint, attach it with the first expression, and then you do the similar thing for g of x. You plug your lower endpoint into the function, calculate the value, calculate g dash x, plug them together, and then when you have both of these expressions, you will just subtract both of these expressions in order to get the answer to this question. So that was a rough idea about how we take the derivative of definite integrals, but if you want to know more about it, I would highly suggest you to first watch those previous videos in order to get the full explanation of what is the process that we are doing in order to calculate the derivative of a definite integral. So this is a 3 or 4 star kind of question, but the process to solve this question is very easy. If you know the approach, the easier approach to solve this type of derivative of a definite integral, you'll easily solve this question under 2 minutes. Trust me, this is the truth, and when we'll start solving this question, you'll also realize this fact that even though this question was a 3 or 4 star question, but the process to solve this question would turn out to be very simple, which you'll definitely notice in the later half of the video. So let's start calculating that. So let me first write the expression again. So we have to calculate the derivative of our definite integral, which goes from x to the power 5 to minus x square for the function cos of e to the power t dt, right? So this is the expression that we have to calculate here. So this is the derivative that we have to calculate in this case. So we'll start with identifying our functions. So in this case, our f of x is clearly cos of e to the power x. Since our function f is in terms of x, is represented in terms of x in this case, we'll change every occurrence of t with x, but please notice that both of these expressions, both of these functions are exactly the same. It won't change anything at all, because in this case we have taken f of x. You could also take f of t, but to simplify everything we learned from the previous concepts, we'll stick with x notation. So we have fx. Now our hx in this case is minus x square. Our gx in this case, hx is, remember, the upper endpoint. Our gx is the lower endpoint, which in this case is x to the power 5. So now let's calculate this derivative. And as we know, we have to first plug in the upper endpoint into the function. So this endpoint into this function, where our x will be changed to the value of the upper endpoint. So this time, the first expression, which is f of h of x, as in this case, would be cos of e to the power minus x square, right? And then we also know we have to calculate the derivative of the upper endpoint. So the derivative of the upper endpoint in this case is the derivative of minus x square. The derivative of minus x square is minus 2x. And we'll do the same thing for g of x. So now we have to plug our lower endpoint into the function. In the same process, it would be cos of e to the power x to the power 5, and then we'll take the derivative of the lower endpoint, the derivative of x raised to power 5 in this case, which would be 5x to the power 4. And now since we have both of these expressions, in order to calculate the final answer, we will subtract both of these expressions. So then when you will do that, your final answer will become minus 2x cos of e to the power minus x square minus 5x to the power 4 cos of e to the power x to the power 5. So this is our final answer, and you would have clearly noticed this thing, that if we knew the approach on how to solve the derivative of a definite integral using this formula, The process to solve this question was pretty simple, right? Even though this was considered to be a 3 or 4-star question. So that is why it's important to know the basic idea about how to solve these type of difficult questions and break down those complex questions into simpler parts so that it's very easy to calculate even a complex question by dividing it into small easy parts and then at last combining all those easy parts to get the final answer to your complex problem. So that was an important point that we covered in this video, that questions may seem hard at first sight. Some of the questions will definitely look hard, but please keep in mind that in order to solve these complex questions as well, if you know the basic approach to solve these type of questions, doesn't matter if it's an easy question or a hard question, if you know the approach to solve these type of questions, the process becomes very easy, even though it seems to be a complex problem. So feel free to comment down in this video if you have any doubts related to this video or related to this concept as well. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.